And the other day, a person from the YouTube asked me, I post a comment on an electronic side about rebuilding or rehashing some old radios that I always do. So he but it wasn't too clear. So he asked me to put a video of what I was talking about. So I agree, and this is the video I agreed to. In fact, is to change a tube radio, the rectifier tube, and replaced by a couple of diodes. Well, as we know, they both do the same job. However, the diodes, being a hell of a lot smaller, are a hell of a lot more efficient also, in spite of the size. So we need to do something else to bring the voltage back, because the diode loses voltage, has a voltage drop on when it rectifies. The diode doesn't. It's only about 1.5 volts that drops. Otherwise it would be getting hot and it would be a much bigger element. But since the tube drops about 40 volts, we need to drop those 40 volts back when we put the diodes. And they accomplish that by a resistor. And it's a process to find out what size resistor we're going to use to drop the amount of voltage that we need to drop. So we need to measure the voltage before we take the tube off, or look in the circuit diagram, the schematics, to see what the voltage was on the B+, and it's supposed to be in B+. Then we put the diodes, we remeasure the voltage we have, and we subtract it from the voltage, or whatever we have to do, see the voltage difference. And voltage is going to be higher, so we just subtract from the voltage that was originally there. And we subtract, it's 30 volts, 40 volts, 50 volts difference, we'll have to find out. Then we measure the current. To measure the current, we have to open the circuit. We need the current to figure out the size of the resistor. So we open the circuit, we measure the current the radio is consuming, and now we have the two elements to figure out the resistor. Okay, we have the voltage, we have the currents, we divide voltage by currents, and that gives you the process by the Ohm's law. They're going to give you the size of the resistor we need to drop the amount of voltage, the amount of volts that we need. That's all. Let's go to it. Okay, now I have the center tap here, and I hook up my meter to the center tap. And I want to measure the voltage we get with the tubing and everything. And see, that's the problem with the stupid thing. Okay, I have in the center tap, I have 350 volts. 350 volts. Okay, so I'm gonna write it down. 350 volts, and then I gotta measure the current. And to measure the current, I will change my meter.
Goes with both envelopes, and he gave Warren Beatty the incorrect one.
He says their picture shows accountant Brian Cullinan was tweeting on his phone and...
Okay, it's working. And I got 420 milliamps. I'm going to write down 400 milliamps. See, there we go. All right. Now that my test is completed, I can disconnect that, unplug the radio, and we'll be ready to put the diodes in. Remove this 3 wire from the high voltage I'm gonna solder that strip terminal. I hold it on one side with a hemostat, and then I have to put high heat right here with a big iron. You need to have a big iron to solder to the chassis. That's one side. Now you can remove the hemostat on the other side that was holding it in place, and solder it in place. Okay, then again, you can't do this with a pencil soldering iron. You gotta have a little bit bigger. And since I don't like the big gun type irons, so now we had to take the two end taps of the two ends to the high voltage transformer and solder it to this terminal strip. Let me do that off camera because it's easier for everybody. Okay, now as you can see, I positioned the two diodes and the terminal strip, and I also put the wire that we're going to go to the B plus. Here you can see the diodes, the band or the cathode, all pointed to the white wire that I added. So make sure the two cathodes are pointed to each other, otherwise you're going to have a problem. But most of you know already, if you're following this video, most of you know already the cathode needs to go to the B plus. Alright, now we're going to solder that. I'm holding the wire with a hemostat so everything stays steady till I solder it together, and it won't be moving around. So now I'm trying to solder it, the diode and the wire, the two diodes and the wire all together at the same time, so I don't have to reheat everything. Alright, that sounds good. That looks good. Alright, now these two wires, then I can remove the hemostat. These two wires, it needs to come, maybe come from the bottom. Those are the two extremes of the high voltage, the two ends of the transformer, and it goes to each side of those diodes. Okay, I'm gonna have to do it separate because they tend to move. Let me cut the extra length of those diode legs. I better know it now than I have to struggle later to cut it off when I have everything in the way. Okay, now I'm gonna solder one of these wires that goes to the transformer, not to the center tap, the two extremes. Okay. That looks good. That is one. And then we do the other one. Let's get this. I don't think I soldered that correctly. Maybe I can fix that right away. Okay. Now, the other extreme from the transformer, it should go to the other end of the anodes on the other diode. I got my finger in the camera away. Okay, that should go over there. Now we should be able to solder the diode and the wire together. Okay. All right. Now we have this part finished. We had to connect this wire that went from the center, from the union of the two cathodes, to the filter capacitor. Now let me reposition this and we'll come back. Okay, now you can see that I soldered this white wire coming from the cathode of the both diodes to the filter cap. Straight. Even if the two filter caps are the same value, please figure it out. This is the first filter cap coming out of the rectifier. Okay? Otherwise you're going to run into trouble trying to get it. Maybe it'll work, but not for too long. It's when you put over voltage in the filtering, it's not right. Okay, now what we have left, the center tap for the high voltage transformer. So before we hook up to anything, we need to measure the voltage. Okay, when the radio is under load. So I'm going to hook up the voltmeter. First I'm going to check up the current. I need to check the current out. And then we're going to check the voltage. I'm going to turn it on briefly. Let's see if we can get the... Oh, it's playing. Well, you can see it's taking 10 milliamps more. 10 milliamps more than it was taking before. So we take that into account. We take that into account. 10 milliamps. Now we're going to check the voltage. Got to move the leads on the voltmeter. 2 volts. Otherwise we're going to have a short circuit. Don't laugh, because many people done that mistake, including myself. Now this one I need to put it to ground before I check the voltage. And this I need to put it over here. Oops, backwards. I need to put it over here. Remember, this is the negative here. And let's check voltage. Let's turn it back on. Okay, there we go. Checking voltage. What did I do? Hold on. I'm not checking voltage here. What's going on? Oh, I'm sorry. Yeah, my fault. My fault. I was checking voltage from ground to ground. Okay. Checking voltage at this point. All right. I really...
Pressure on Highland, which is always so
I am reading 335 volts. 335 volts. Alright, now let's check out what did I have before, and then we figure out what kind of resistance. 345 volts. And before we had 350. So we're right there. We don't need to do anything actually. Let me check on the other. Oh, 300, I'm sorry. Yes, we do. We had 293 volts there before. 293 volts. And we had 335. So we had to drop 30 volts, basically. So if we go to Ohm's law, we had around the number 400 milliamps, and then we had to drop 30 volts. Alright? So the Ohm's law said we had to drop 30 volts at 0.04 milliamps. If we do divide the division, 30 times 0.04, it comes to a 620 ohms. 620 ohm resistor we need to put out there. Let me find one and we'll come back. Well, I'll find myself a resistor close enough. It's a 500 ohm resistor, and we'll check the voltage now with that resistor and line. I don't know if you can see the voltage there.
What happens when you run into Andrew Martinez and he knows that you name your cat Griffey and not Martinez?
Okay, wow. Let's stabilize.
Harold Reynolds is not going to be happy with you.
Okay, it's 298 volts, 297 volts. And we're supposed to have 293. Close enough.
That's stupid. He just does dumb things. Like tweeting pictures of a cat they named Griffey.
We're supposed to have 293 where the tube was measuring. However, we didn't know the efficiency of that tube before we started. So I'm going to install that 5 watt resistor in there. It's going to get a little bit warm, but I don't have a 10 watt resistor right now. I'm going to install till I go to the store, but I don't want to go to the store for a 10-cent resistor just for that. Let me install that resistor and the way it's going to look after that, and I'll come back. Okay, now you see in one terminal strip we installed the whole jigamaround, not the terminal strip on the side, because it's hard to find room out here to put the terminal strip. So I choose to put it to the reach of these wires, so I don't have to patch the wires and extend them. So I put the 2 diodes and the resistors. And from the center of the two, from the cathode where the 2 diodes meet, back to the filter cap. And I figure out the drop-in resistance, I figure out how many milliamps the radio is using up, and the voltage I had to drop to the original voltage. So you divide the voltage by the milliamps, and it's going to give you the value of that resistor. The voltage drop that you need. The difference between the original voltage that you have with the tube and the voltage you're getting with the diodes. You measure the voltage drop, and then, or you calculate the voltage drop because you measure both of them, and then you divide the voltage by the milliamps, and you get the value of the resistor. And that's it. Simple as that. I left the wires for to the heaters for the tube hooked up. So if anybody looks, everything is excellent and original. It doesn't look like you ever change anything. Even if you turn the radio over, you see some connections to the tube and some extra connections are here, but Nobody's going to figure it out unless we are technicians, you know, we are savvy, that we replace a tube by a couple of diodes and a resistor. And that's all, folks.
That's her father. They were with her last night.
Please notice that I replaced a cord by a three-conductor cord, and a three-conductor, since it's a transformer chassis, I can put the hook up the ground to the chassis. So you can do that too when you're restoring this radio, make it safer. And just put a three-conductor cord and solder or hook it up somewhere, the ground to the chassis. Okay, that's a safety feature. Thank you. Okay, this radio's ready to be put back to the
Up to the shoulder. We're over the 10 right now.
La pregunta que está haciendo.
Ajá. You can make any argument like that because who the hell knows that that's a functional organization? I mean,
Hey, I'm sure you won't be in any trouble.
John and Ken.
Okay, it works perfect. It's ready to be back into the cabinet and put it away. Another radio successful rehatch. No problems. Thank you very much.